Hello, my fellow flat earthers and truth seekers. I have some exciting discoveries to show you today. I understand there are many questions and claims floating around lately about Antarctica and whether or not if there is a midnight sun there or only sunlight. Many questions over the so-called final experiment expedition. Was it real? Was it faked? A mixture of both? Did the observations at Union Glacier speak for the rest of Antarctica, or were they only local observations? How do these observations here differ from TFE's observations? After seeing this footage, I hope we all get closer to the truth. I would like to thank the YouTube channel, Following the King, for this footage we are about to see. You can find their link in the description. Please go there and subscribe. There were a few minor time errors in the video, but they corrected them in the description. They are on display here, and you can find them at the original video. Without further ado, let's get to the video.
Witnessing the midnight sun in Antarctica. We live on a flat earth with a firmament. As believers in Scripture, we were called to witness the midnight sun in Antarctica. We trust His word and believe we live on a flat earth with a firmament, and the sun and moon are lights in the firmament as written in Genesis 1. A video explaining this in detail is How Does the Bible Describe Earth? Elohim made the dome and the greater light, sun, and the lesser light, moon. I am Yahuwah, and there is none else. Repent, and be baptized in the name of Yahushua HaMashiach. Forget not my Torah, but let your heart guard my commandments. All glory and praise to Yahuwah, who sent His only Son Yahushua, who died for us to be set free. General information. Before we begin, we must apologize as all timestamps are set for +10 Brisbane time zone. We were in +11 Melbourne time zone with daylight saving. Therefore, all images and videos with a timestamp require 1 hour added. We have sped up or slowed down videos, but we have not used any filters on any devices, except for a solar lens filter. When looking for sunspots, at the beginning of the flight, we did not realize how dirty the plane's windows were. During our flight, we cleaned the plane's windows. During this video, we have provided the most accurate information we could. We were not able to recheck this information, as we only flew on this flight once. We obviously need others to confirm this information we have collected. This is the flight path we followed as indicated by Flight Radar 24. Using this information, we can make approximate times for 5 p.m. departed from Melbourne, 9:30 p.m. arrived in Antarctica. The pilot told us it was about 4 hours of flight time to see ice. 1:45 a.m. departed from Antarctica, 6:30 a.m. arrived in Melbourne. Using a flat earth map, this is the area we explored from the air. Flying to Antarctica from Melbourne, the sun was getting closer to the horizon and was moving further away. We were traveling south, yet the sun was traveling west. During this flight, we had a number of cameras to use to record the journey. They all recorded differently during our flight. Lens flares became more prominent as we flew towards Antarctica. It is not recommended to point a camera lens at the sun. Flying across Antarctica. During the journey to Antarctica, the sun was getting further away. The sun was moving slowly down onto the wing of the plane and the sky was getting dimmer. At 9:54 p.m., the sun changed suddenly and noticeably. The sun became very bright and very white, and it became very difficult to look at the sun. People started putting on their sunglasses to ease the glare. The sun also stopped going down from our visual perspective and started moving higher in the sky. This was easy to observe as we were on the wing and could see it change suddenly. This is what we witnessed. The sun was coming down onto the wing of the plane. Then the sun stopped suddenly and started rising up and getting brighter, wider and bigger. The sun continued to rise and get brighter as we flew until around midnight. We believed we were no longer seeing the real sun, but we were actually seeing a reflection, mirror image, of the sun off the firmament. Does light reflect across a glass surface, aka firmament? This experiment does not replicate the sun in the firmament. However, it does show that light travels across a glass surface. This model shows the sun moving to the left side and the reflected sun coming from the right side. This did not happen in Antarctica. When we flew to Antarctica, the sun was always visible. The sun changed direction. The sun stopped going down and started going up. Intensity. The sun started getting brighter and whiter. Size. The sun started getting bigger. The sun never disappeared from our view during our flight. The objective of this model was to show that light does shine brightly from one side of the bowl to the other side of the bowl. Look at the small spot above each reflected sun. They are not lens flares. The reversed inverted sun is above. The reflected sun, like a rainbow, is much bigger and brighter. Again, as we were leaving Antarctica, the sun was not as bright and white, but became more yellow, and we saw the sun coming from the east, which was behind the plane. During the entire flight, we were watching either the sun or the sun's reflection off the firmament. We never saw the dark of the night. From a scriptural perspective, the book of Enoch tells us that the sun travels clockwise in the firmament across a flat earth. When it is summer in the southern orbit, the sun travels clockwise in gate 1 for 31 days and 30 days. Hence why there are 24 hours of daylight in Antarctica around this time of year. There are some great videos on describing the gates that the sun and moon move through, Enoch 72 to 75. We recommend watching this video by The Organized Earth. This video describes the sun from the northern ring perspective, not the southern ring perspective. Even though this video by The Organized Earth is a good explanation, it requires clarification on 3 points. 1. The sun and moon start the year in gate 4, not gate 1. 2. The start of each year is at the equinox around March-April. 3. The sun progresses through the gates as follows. Here is a screenshot from a reel by Uncommon Ground titled, The Solar Analemma and the 6 Gates of the Sun. An analemma is a photograph of the sun taken at the same time every day from a fixed location for 1 year. This elongated figure 8 shape is easily explained on a flat earth with a firmament using Enoch's 6 gates. This video by GeoTruth explains how a 24-hour sun is possible on a flat earth with a firmament. Navigation data proves firmament. GeoTruth makes a claim that there is an error on the Gleason's map. We can confirm that there is indeed an error on the Gleason's map.
As expected, 24-hour sunlight occurs from minus 66.56 degrees latitude to minus 90 degrees latitude. Perfect mirroring is occurring due to the crystalline firmament. 24-hour sunlight is occurring at minus 66.56 degrees latitude to minus 90 degrees latitude. The navigational data of sunlight coverage in Antarctica during its summer months shows 24-hour sunlight. Therefore, the Gleason's map, graphic, and description of sunlight coverage during the December solstice is not correct. The Gleason's map does not recognize the perfect mirroring of sunlight at the equator caused by the crystalline firmament.
We saw what we believe to be the reflected sun while flying over Antarctica at midnight. Our first glimpse of ice. Check out the full circle around the reflected sun. 1:11 a.m. Is that the sun reflecting off the firmament? It almost looks like a rainbow. Rainbows reflect off the firmament too, and hence why they are arced. Rainbows need a glass surface to reflect off. The firmament is that reflective surface. So a lure made the dome and separated the waters that were under the dome from the waters that were above the dome. And it was so. The double rainbow has its colors reversed or inverted because it reflects off the firmament. A full circle rainbow with a reversed or inverted rainbow on the outside. Do you see what rainbows and the midnight sun have in common? Rainbows and the midnight sun are reflections off the firmament. Departing Antarctica to return to Melbourne. On the flight from Antarctica, the yellow of the sun returned, so we believed this was now the real sun. The bright, white light from the reflected sun was no longer seen. It was very difficult to capture the sun on the return flight, as the sun was coming from behind us most of the journey. Hence, it was difficult to see the sun through the plane's window. See how the sun shines through the clouds. How amazing is Yahuwah's creation. Towards the end of the flight, we were able to record the sunrise. Notice how the clouds that are close to the sun are lit up. Let's watch part of this video again in slow motion. If the sun is about 150 million kilometers away from Earth, how come only some of the clouds are bright? Finally, the pilot turned the plane slightly to the right and we could see the real sun. We were treated to manna from heaven. How amazing! Compass directions are reversed in Antarctica. During the flight, this explanation was provided about why the directions on compasses are reversed in Antarctica. Remember, on a flat Earth with a firmament, we do not have a south geographical pole. North is at the center, and south is opposite on the outer circumference.
So if you think about that, you're going to end up with the north end of the compass pointing to the south geographic pole. It's astonishing. You've got to really think hard about this to get your head properly around it. But the north end of the compass is pointing at the south geographic pole. And as a result, in order to travel west, you have to travel compass east. And when you're coming back towards the east, you have to travel compass west. So you really have to trust in your knowledge and your instruments to make that transition from what is a normal, or what you think is a normal way of which you should be travelling, or which way a compass should be pointing. It's a pretty tricky one, but think about it.
Let's examine what he means using Google Earth. We flew from Melbourne, Australia to Antarctica. This flight was in a southeast direction. Compass directions are correct. Once in Antarctica, every time the pilot wanted to travel west, he needed to travel compass east. When heading back to Australia, every time the pilot wanted to travel east, he needed to travel compass west. After leaving Antarctica, the pilot could now fly northwest with compass directions being correct again. This means east and west in Antarctica looks like this. East and west are reversed. Remember, this only happens in Antarctica on a globe. So if east and west are reversed, then north and south are reversed too. We have to keep the compass points in the correct order. Never eat soggy wheat bix. This reversed, or upside down, compass is how pilots navigate when flying in Antarctica. Instead, let's try navigating Antarctica on a flat Earth map. Before we do, let's clarify our compass directions on a flat Earth. North is the center point. South is always opposite north. South is the outer circumference of Earth, which is Antarctica. East always travels anticlockwise, west to east. West always travels clockwise, east to west. We flew from Melbourne, Australia to Antarctica. This flight was in a southeast direction. Once in Antarctica, every time the pilot wanted to travel away from Australia, he needed to travel east. East is following along the coastline of Antarctica. When heading back towards Australia in the opposite direction, the pilot needed to travel west to follow the coastline of Antarctica. After leaving Antarctica, the pilot flew northwest. Notice how the directions on the compass never reverse on a flat Earth map. This is the compass used on a flat Earth with a firmament. This is the same compass used everywhere else, including the North Pole. Which compass makes more sense to use in Antarctica? An upside-down compass used on a globe, or a normal compass used on a flat Earth? Why do compasses not work on a globe? On a globe, Antarctica is a circular continent at the South Pole, so it appears the pilot needs to travel west to go around the perimeter. On a flat Earth with a firmament, Antarctica is the outer circumference of a circle, so the pilot needs to travel compass east to go around the perimeter. On a globe, traveling the opposite way, the pilot needs to travel east to go around the perimeter. On a flat Earth with a firmament, the pilot needs to travel compass west to go around the perimeter. Vendée Globe Race. To help with understanding, let's take a look at how yachts sail around the flat Earth. Thanks to Sweetheart by Jenny for providing the following animation of how boats sail in the Vendée Globe Race on a flat Earth. The skippers in the Vendée Globe Race believe they are traveling west around Antarctica's coastline, but they are actually traveling east. Compass directions while flying to and from Antarctica. During the journey, we checked our direction of travel on a compass we brought. We would lie the compass on the armrest in the direction of travel, so later we could confirm the direction of travel of the plane. This photo was taken at 10:43 p.m. It showed that the plane was heading in an easterly direction for the majority of the plane trip to Antarctica. We are aware that the north needle is meant to face north on the compass. However, we made the compass face north in the direction of the plane's travel. Then we could refer back to the compass needle in our photos to obtain the correct direction of the plane's flight path. This photo was taken at 4:17 a.m. It showed that the plane was heading in an almost westerly direction for the majority of the plane trip to return to Melbourne. The flight path on our screen did not always match the flight path on our compass. The plane was flying south according to the screen. However, our compass says we were flying northeast. The first image had the compass facing in the direction of the plane's travel, and the second image had the compass facing north. Therefore, looking at a Gleason's map, we could see that on the flight to Antarctica, we were traveling southeast, then turned east to follow parallel to Antarctica's coastline. On the return journey, we were following parallel to Antarctica's coastline in a westerly direction. Then we turned northwest to fly towards Melbourne. Jet streams move in an anticlockwise direction around Earth, so it is faster to travel west to east than east to west. This video, titled Pilot Speaks Out, explains jet streams well. Photographing sunspots on the plane. Previously, we have taken many videos and images of sunspots. The following set of images are taken with a solar filter attached to the Nikon P1000. It makes the environment look like it is night, when it is actually daylight. These are sunspots we have previously photographed in Queensland, Australia, standing on land. These are the sunspots we took from Melbourne standing on land at 9:16 a.m. in the morning before heading to the airport. Sunspots are visible while flying to Antarctica. Can you see the reflected sun in the reversed or inverted sun? The most amazing footage of the flight, with P1000 and solar filter.
So far, we have noticed a few differences in observation data from the final experiment's footage. Witnessing the sun going from yellowish and normal looking to a sudden, bright, white glare is the first. The sudden movement upwards was something not witnessed either, but the inability to no longer see sunspots is very interesting and revealing. How come at Union Glacier were sunspots seen, but not here? I'll let the viewer ponder that question, but we are seeing some stark differences here. It's well understood by many that there is a history of manipulated and edited footage of a 24-hour sun from Antarctica. Could the reason be that there is a type of midnight sun in Antarctica, but it is so incredibly different from the northern midnight sun that some people and universities decided to create counterfeit versions? Does it behave differently depending on your location around the ice ring and firmament? I'll let you ponder those questions. Let's continue.
We were never able to photograph sunspots while traveling over Antarctica, but we did photograph the reflected sun and the reversed inverted sun.
Interesting.
Interesting.
To conclude, here are some photos and videos of Antarctica. Interesting information on the flight.
The saltiest water on the planet. It is 40% salt. It doesn't freeze even when the air temperatures get to -50.